Hey everyone, Geophysicist Stefan Burns here. The mystery of Interstellar Object 3I Atlas is deepening day by day, though we are starting to come to some better understandings of what this interesting interstellar object actually is. Some big updates for you today. I'm going to be going through a complete breakdown as to everything that we know on 3I Atlas. Now, it has its closest approach to Earth rapidly approaching. That will be December 19th. So as I record this today, December 3rd, that is just about 2 weeks away. And that's coming after its perihelion, its closest approach to the sun, which was on October 29th. And that's when it's receiving the most solar radiation possible. Also, it was hit by a ton of solar storms just before that perihelion. So it had a lot of energy that was put into it. And we've been tracking interstellar objects since July 1st when we first picked it up. Then we looked at some earlier sky catalogs and picked it up there. And so we've been tracking its evolution as it's gone closer and closer to the sun. In deep interstellar space, it's receiving very little energy, though it is having galactic cosmic rays hit it. But the overall radiance, like the energy of radiance, is expected to be about 10 to the negative 7, 10 to the negative 8. When it's as closest to the sun, it's calculated to be 735 watts per square meter. Huge difference. So you would expect that there would be some pretty significant changes that would happen with 3I Atlas as it goes from deep interstellar space for an unknown duration of time it's spent there to close proximity to our star. And that's the first time in at least 10 million years that's been close to a star based off of our understanding of its orbit and its trajectory and looking at our all-sky Gaia catalog and seeing that basically it didn't pass within any nearby stars for the past 500 parsecs, and that equates to 10 million years. So as we've been tracking it through the solar system, all these anomalies have popped up. The most significant one now, I would say, is the sunward facing tail. And as the rest of 3I Atlas is now dimming post-perihelion, it's losing brightness. Its main anti-sunward tail is not as long, it's starting to dim in brightness. The sunward facing tail, which is quite anomalous already, is getting bigger and brighter. So that's quite weird. But when we first picked it up, we got a lot of spectroscopic measurements of it, which tells us the molecular and elemental breakdown. And then as it got closer and closer, we started noticing unusual changes. Specifically at 2.5 astronomical units, all of a sudden it rapidly brightened by 2 in apparent magnitude, which was quite significant. You typically don't see that from comets, and if you do, it's a cometary outburst which then subsides again. This was a complete increase in brightness, which then did not subside. In fact, it accelerated going into perihelion, showing some sort of change with 3I Atlas. And well, there is quite a bit of evidence that in fact, what occurred was that the entire object, comet, whatever you want to call it, had a burst of cryovolcanism across its entire surface. And what I find so interesting about this is that all of our information that we've gathered on 3I Atlas, in addition to a lot of information that we gathered on other celestial objects like trans-Newtonian objects, the different asteroids in the asteroid belt, centaurs, and more, they've helped us to kind of understand what 3I Atlas is and how it's evolving and the unique properties of 3I Atlas. Because at that transition of 2.5 astronomical units, where it brightened dramatically, that's indicative of there being catalytic processes that were active, allowing for this rapid brightening, the cryovolcanism, right? This sublimation of ice straight to water and water vapor. And when you have that, you actually develop magnetite crystals. So these are magnetic minerals. And as a result of that, 3I Atlas has actually been building its own inherent magnetism and its magnetic field in addition to its induced plasma magnetic field as it's traveled in our solar system. Additionally, we just got new information from the Osiris-REx mission, which basically was an impact on asteroid Bennu, and we gathered samples and brought them back to Earth. This is a B-type asteroid, and now we have found all the main building blocks of life from that asteroid. There is glucose, you have all the nucleotides, amino acids, even like briny mixtures and water. All that's been found on asteroid Bennu. That news just dropped. And well, asteroid Bennu is quite similar to 3I Atlas. In fact, these compounds that you find on B-type asteroids are much more enriched in D-type asteroids, which are similar in their spectral characteristics to 3I Atlas. And also there are carbonaceous chondrites. These are CR carbonaceous chondrites, a very specific type, which seem to really be similar in their characteristics to 3I Atlas and how they first formed basically outside the protoplanetary disk, remaining effectively like an untouched specimen of the early formation of the solar system. They have very similar characteristics to 3I Atlas, and they're very rare, these CR chondrites. And well, they're also super enriched in organics. So as 3I Atlas has gone closer to the sun, it has built this magnetism inherently from the production of magnetite through these catalytic processes. And there's evidence that, of course, 3I Atlas has a lot of nickel and iron, and well, these CR chondrites also have a higher nickel-iron ratio, and that provides a catalytic substrate for these sort of reactions, which then produce organic compounds. So we have 3I Atlas hurtling through the solar system containing probably, we can't say for certain without in situ measurements, but based off of everything surrounding it that we know, almost certainly containing all the ingredients necessary for life as we know it. And it will be passing close to the Earth on the 19th of December. And then we will be going through the zone of space where it was during its perihelion, its closest approach to the sun, next May and April. So very interesting things happening with 3I Atlas. The cryovolcanism is really apparent with those huge jets which were bursting out of it post-perihelion, going out to 50,000 kilometers. Now it's cooling down, but how our solar system has permanently changed this unique interstellar object and how it's perhaps permanently changing us in the process is still very much a mystery, though we do have more information, and let's get right into it. So a lot of this information that we have on 3I Atlas is based off of spectroscopic observations of this object across time. What's going to be interesting now is seeing how it changes post-perihelion as it travels further and further out into the solar system. So it's going to swing by Jupiter. Unless it does something crazy, it's going to keep going out and eventually leave the solar system. And we'll be able to track it that entire time, watching its evolution as it moves away from the sun, which is going to be interesting. But we see a lot of similarities between 3I Atlas and carbonaceous chondrites, specifically metal-rich CR carbonaceous chondrites. And that comes from a specific deposit of these carbonaceous chondrites that was picked up in Italy. They're very rare, and they're believed to have formed outside the protoplanetary disk. So you have this disk, the stellar disk, the protoplanetary disk, all the planets are forming, the sun is forming, and then these CR chondrites, based off of their mineral composition and a lot of the other things that we picked up on them, they appear to have aggregated post the formation of our solar system from whatever residual was already out there. So there's a lot of overlap in terms of just basic spectroscopic data and what we know between 3I Atlas and these CR chondrites. What's interesting about them is that they have a lot of water, they have a lot of iron and nickel, right? 3I Atlas is not completely depleted in iron. There's people have gotten a little carried away with the nickel thing. It has a lot of nickel in its coma, and its coma is more oxidized. That was indicated by the presence of carbon monoxide and especially carbon dioxide. But it has a lot of iron, okay? It's just the nickel to iron ratio was elevated. So there is a lot of nickel there. Well, we see that in metal-rich CR carbonaceous chondrites. And what happens is if they get close to the sun and they undergo these catalytic processes, you discover all of a sudden magnetite, which is a mineral, Fe3O4, that is the magnetic mineral of choice. You have magnetite and titanomagnetite. And you find that scattered all across the Earth, and that can form regional magnetic fields. And on Mars, we get the same thing. It's the strongest magnetic mineral that we know of, or at least that I know of. I don't think there's any other magnetic mineral that's stronger. I mean, we have neodymium magnets, but those are made, right? So like a natural magnetic material, magnetite lodestone, that is very interesting that this can form its own regional magnetic field after it's starting to approach the sun, whereas perhaps it didn't have that before. And then what we also see are there are these reactions that occur as a result of the nickel, because that acts as a catalytic substrate to produce then a lot of organic compounds. And now we have strong evidence from that asteroid Bennu mission of asteroids, even B-type asteroids, which are more depleted in these organic compounds than like a D-type asteroid. The further out you go, the more there are typically, of there being nucleotides, there being amino acids, there's being glucose, the building blocks of RNA and DNA, and more. So 3I Atlas is almost certainly enriched with organics and volatiles that it picked up during its interstellar journey of who knows how long. The estimate is roughly 3 to 11 billion years, but we really don't know. And because it hasn't passed by a star, we estimate for 10 million years at least, based off of our all-sky surveys and the current position of the stars and where it came from, that means that it hasn't undergone any processing by a close approach to a star in a long time. Only interstellar galactic ray processing, which produces these organics and also further kind of refines these volatiles and organics into more complex forms. Then what we saw was a rapid activation of 3I Atlas at 2.53 astronomical unit. There was a sudden 2 apparent magnitude brightness surge to this object, and that is indicative of not just localized cryovolcanism, where there's one spot where you get a sudden sublimation and then you get this outburst, but the entire thing did that. So it's looking more likely day by day that there is a cryovolcanic surge that began, and then it really rapidly accelerated post-perihelion, because that's when we saw all the jets coming off of it, right? All the amateur astronomer photos from November up to effectively now, we're still seeing some of these jets, show tons of jets off of 3I Atlas, as we've covered on this channel. The other piece of evidence for that is that it has a 16-hour rotation. So if it was really slowly rotating, let's say like 5 days or something, then the solar radiation hitting it would be fairly uneven, but a 16-hour rotation is actually pretty fast. So the solar heating effect is fairly homogeneous across the surface of 3I Atlas. And that's further evidence that this was a global event, you could say, across the entire surface of 3I Atlas. And because of its interstellar journey, it would form this little crust of volatiles, organics, and ice and more that would then rapidly volatilize when it got enough radiation. Whereas objects that have swung in close to the sun before, like most of the comets in our solar system, even though maybe they have a 70,000 or 200,000 year orbit, they've done it many, many times, unless they were just recently disturbed. So they've done that before. For Interstellar Object 3I Atlas, that's probably the first time that's happened in a long time. And let's say it happened 100 million years ago with another star system. Well, then it had 100 million years to build up this unique interstellar material crust, which is now undergoing this process, and the core of it effectively remained unchanged, bearing a lot of iron and nickel. And the chemistry of the coma, which there's been a lot of talk about, the carbon dioxide to water ratio being 8:1, that's 4.5 standard deviations above what's normal in our solar system, right? Showing that it's heavily oxidized. The high levels of carbon monoxide and also nickel show this processing in action. And so some people were speculating that this was industrial in nature, but we see with very specific like CR chondrites that you can have this sort of oxidation occur. And that there are natural processes to account for that. And it's not unusual for comets or asteroids or other objects like that to have nickel within them. So it's not like nickel is completely devoid in the solar system. In fact, there's a ton of nickel in the Earth, the iron nickel core, right? Both inner and outer. So nickel itself is not some weirdo thing. It's the nickel to iron ratio, which is quite unique to 3I Atlas, but we do see other things. We have limited evidence with other things that we picked up, like the CR carbonaceous chondrites, which are fragments of what's suspected to have been one asteroid that was out beyond the solar system, that have very similar properties to 3I Atlas. And the big news out today, which informs us a little bit more as to what 3I Atlas may be and what it may be carrying, is that we've basically found all the essential building blocks for life on asteroid Bennu. So we already knew that they had the RNA molecular components. That information came out earlier this year, perhaps even a little bit before that, but I saw something for February of this year. So the main building blocks of DNA and RNA. Now we have detected ribose here, which is a building block of RNA, and then also glucose, which is an essential component of metabolism, just energy production. So this is a 5-carbon molecule. This is a 6-carbon molecule. All of these have a lot of carbon. They have a lot of nitrogen, right? You have hydrogen, you have oxygen. So the moment you get nitrogen and you get water in there and you get some carbon somehow, right? A carbonaceous chondrite, you basically have all the building blocks. And so what we haven't found is like a complete RNA segment or DNA segment. But effectively, we have everything now, at least based off of asteroid Bennu, for that. And asteroid Bennu isn't anything special, right? There's a whole bunch of these asteroids in the asteroid belt. There's millions and millions and millions. And it's not even that special of a type of asteroid, it's a B type. So it's been more processed by the sun, and therefore it's less likely to have these compounds compared to, let's say, like a D type or a trans-Newtonian one. These trans-Newtonian objects like Sedna or Maki-Maki out beyond the edge of Neptune, and they really go out there. Sedna goes out to 1,000 astronomical units. That's well outside the heliosphere. They have this distinct dark reddish surface color to them, and that's what was picked up with 3I Atlas at the beginning. It had a very similar optical color as these trans-Newtonian objects, and that's believed to be this crust that's picked up from the interstellar medium that's rich in these organics and volatiles and more. We also found a ton of water on asteroid Bennu, because just because it's space doesn't mean it's freezing cold near absolute zero. The closer you get to the sun, you actually have quite a bit of heat. And so the dark side is going to be cold, the light side is going to be hot, then you have these transition zones, but it's possible to have water on these things. It doesn't have to be just ice or just water vapor. There can be liquid water, which is necessary for these catalytic conversions to occur. And so asteroid Bennu is depleted in a lot of things that would actually help to create these organic compounds, amino acids, and more. 14 of the 20 essential amino acids for us were detected on Bennu, 33 in total. But if you take a D-type asteroid, I'm sure that we probably get a much higher ratio of these organics, like, you know, just more concentrated and maybe even more complex. Maybe we finally would find actual genetic code on these things. It's possible. It really seems that this space environment is just like a Lego factory, and the blocks eventually start to stack, and then you get things to get built, and maybe the early Earth was seeded with all the stuff needed from asteroids and more, or even later times, or now it's still happening, and this shares genetic code and information, perhaps not just across the solar system and the planets within our solar system, but across the entire galaxy. That's possible. So with all this information, 3I Atlas could be a seed from a different star system. Asteroid Bennu is showing that all the building blocks for life can be found on asteroids, and water is a key component of this. Asteroid Bennu had water. 3I Atlas, we saw that carbon to water ratio. So we know that there is H2O there. It just has a lot of carbon dioxide, a lot of carbon monoxide, but it's not depleted in water, just like it's not depleted in iron. It just has a lot of nickel for that ratio. It is effectively a compositional twin to organic rich meteorites, these CR carbonaceous chondrites, which are known to be very abundant in amino acids, even more so than asteroid Bennu. So 3I Atlas in this way is like a seed of life from another star system, at least for life as we know it. And then if we evoke the unknown of what we don't know, right, then this could also be carrying things beyond our comprehension and understanding that are life in some aspect. We really don't know, but we will be passing by the orbit of Interstellar Object 3I Atlas during its perihelion very, very soon. We can look at the sky live right here. This is its perihelion location, October 29th. We see that it was effectively behind the sun for us, just slightly outside of that exact alignment, which was on the 21st of October, okay? But notice position here. It's inside the orbit of Mars, right in this zone. Now, if we go forward, we'll get to today, the 3rd of December. Now we're getting really good observations of 3I Atlas. We're about to look at some of those. This new sunward facing tail jet is really, really big. And then it's going to continue on. So if we go forward, we see that it starts to get close to Jupiter in February, and then in March, middle March actually gets its closest to Jupiter. That'll be very interesting. If we actually go back really quick, we'll go to the 19th of December. That is the closest approach of 3I Atlas to Earth. So it's not that close in the grand scheme, but it is the closest it will get to our planet, which is interesting. And you see that they're fairly closely aligned as it relates to the sun and perhaps solar storms launching out. If we go forward, that is even more true in January. So if this is triggering solar activity, which that seems to be the case because all the big sunspots of the past couple months formed right as they rotated into view of 3I Atlas, then they started going crazy. This could be a very critical time window for that. But if we go forward again, now you'll see that Earth is getting close to that perihelion transit zone. So we go forward like this, and we see that now if there was any stuff that 3I Atlas left in space, Earth could swing through it during this time period of March to April. And remember, it had these huge jets, right? These massive jets, 50,000 kilometers extending off the nucleus and coma of 3I Atlas. It was clearly pumping out a lot of material. We saw the rapid change in brightness for 3I Atlas at 5.3 astronomical units. Let's check out that data because it confirms that there basically was a global cryovolcanic event with this object pumping all this material out across space. And again, it has all the building blocks for life, almost certainly. And here we have our light curve for Interstellar Object 3I Atlas. So we can observe this dramatic change that occurred around 2.5 astronomical units, which is indicative of cryovolcanism having suddenly occurred across the entire surface of that object. So we see that here is first picked up July 1st of 2025, and it followed this standard increase in brightness as it got closer, but right around the 7th of September, it suddenly got quite a lot brighter. We can zoom in on that, and you see it was right around the 7th, it suddenly leapt up in its apparent magnitude by about 2, and it wasn't just a transient thing like we see with comets and these cometary outbursts, which then the brightness subsides, or maybe goes back to like the trend line that it's following as it increases. This was a sustained increase in brightness, which then continued all the way through its perihelion. This red line right there denotes that date. You see now it is decreasing in brightness as it moves further away from the sun. But that clearly was a very significant event that occurred in early September, indicating some sort of state change with 3I Atlas. And well, what we see is that water, liquid water specifically, can exist at 2.5 astronomical units. So there's evidence for that based off of like phase diagrams and more. So we see that that's possible based off of the solar radiance at that zone around the sun. And we see this state change with Interstellar Object 3I Atlas. We know that it's rich in water. And well, this is more proof that this cryovolcanic event and the catalytic conversion of a lot of different volatiles and of magnetite, right? The creation of magnetite and then of these organics exist. Because what you're doing is you're taking that water and you're separating off the oxygen, attaching that to the iron, so it's Fe3O4, that hydrogen now is free and floating and can join a carbon and some of the other oxygen to create amino acids and more. You just need a little bit of nitrogen and a few other things here, phosphorus and sulfur, and boom, you got amino acids, you got nucleotides, you got all the things you need for life. And so there's going to be concentrations of those because of its interstellar travel, and it's just slowly going to accumulate these things as it moves through the interstellar medium. And because, you know, stars explode, they produce all these elements and they just scatter it out throughout the cosmos, right? There'll be low density and low concentration, but do a long enough journey, you'll get what you need. And then you get close to a star like our sun, and well, let's turn on the life factory. So this interstellar object, I mean, we don't know what it's enriched with now in terms of the building blocks of life as we know it, but it could be really interesting on the surface there. I mean, at what point do these building blocks stop connecting together to actually produce life? Is there like a hard limit where, oh, it's just blocks, but it doesn't actually form life? Or can there be a runaway where now you have like primitive unicellular organisms? We don't know. This is all totally new science. So it's possible that there is life on interstellar object that has been created as a result of its close approach to the sun. I wouldn't say it's a high possibility, but it's a hypothesis that can't be ignored considering all the information that we know of 3I Atlas that we've collected and based off of all the observations that we've collected of various asteroids, comets, and more across our solar system. I also find it really interesting that a key part of this process is the creation of magnetite. And we know that here on Earth, life is able to exist because we have a magnetic field. Because if there wasn't a magnetic field, then these cosmic particles would be coming in at a much higher concentration to Earth, and that causes DNA strand breaks, either single or double, and then you get mutations, and well, it's just too harsh of an environment for life. Life is self-replicating, but it needs a little bit less cosmic flux to do well. So thankfully, we have a magnetic field here on Earth. The fact that you create magnetite as part of this process when you're creating these organics is very interesting because that is going to start to create a magnetic field around 3I Atlas. We don't know to what strength, but we already know that it has a magnetic field because of the plasma around it. The gas and the dust that it's emitting into space get ionized, and so you form an ionopause around the comet. Then you also form a cometopause, and that magnetic barrier can have a strength of about 30 to 50 gamma, or 30 to 50 nanotesla. That was what we observed with the Rosetta mission. And then when a solar storm hit that comet, it strengthened to 300 nanotesla. So the magnetic field around a comet can already be quite strong. And then you have endogenous production of magnetite on the surface, and perhaps even deeper over time, it like sinks in. Like the magnetic field around 3I Atlas could be quite significant, and that is going to help with any sort of compounds, organics, or even life that is there on that spaceship, that interstellar spaceship, let's call it, that's moving through. So all the different things converge together to tell this really interesting story, which I find absolutely fascinating. Let's look at our latest imagery. Here we have a new image of interstellar object 3I Atlas by Dr. Sebastian Voltner, and this was taken on December 1st by a telescope in Utah. And here we see it very, very clearly with that sunward facing jet/tail. So its anti-sunward tail is starting to fade, become a little bit more diffuse and not as well defined. But this is the most clear that I've seen, this sunward facing tail for 3I Atlas across all the different photos from different amateur astronomers and more. And it definitely is following a progression where this is getting brighter and also longer with time, which is quite unusual because the rest of 3I Atlas is dimming. So this is our absolute latest imagery. We don't know what 3I Atlas is, but there's clearly evidence, as we just explained, of there being a lot of organics, the building blocks of life, of there being magnetite, magnetic field, plasma processes, all these things. And so we have a very unique and special transit, you could say, occurring right now with this interstellar visitor flying through our solar system the closest approach to Earth, again, December 19th, and will be flying through that debris stream that it created around perihelion going from March to April. So that's going to be really interesting because how much stuff is going to rain down into the Earth? Like, I don't think people are going to be going outside and be like, oh my God, it's the comet stream, though it's possible. But just like, is that how Earth was originally seeded, with these sort of materials for life? And how many of those things is that needed? Right? How many comet impacts or flybys are needed to get life kind of turned on? How is this going to interact with life that we have here on the planet? These are all hypothetical speculations, right, and questions that you can ask. But based off of what we know, they're interesting things to think about. That's a ton of information, so let's wrap up with a very clear best timeline of events based on the known data for Interstellar Object 3I Atlas. I really think that this is pretty close to probably what is actually happening. It's not going to be 100%, but this seems to really be hitting close to bullseye, at least based off of my analysis and my intuition and more. So make sure you read the research papers if you really want to understand this better. And if you've been tracking this for a while on the channel, then you'll see why I say this. Okay, so I'm just going to read straight through this. 3I Atlas is likely an ancient survivor from a far distant star system with an estimated age of 3 to 11 billion years. 3I Atlas has not experienced close stellar flybys within the past 10 million years, or 500 parsecs, based on a careful study of stars included in the Gaia DR3 catalog. The best size estimate for 3I Atlas is 0.3 to 5.6 kilometers with a 16.16 hour rotation period. A fast-moving body in the interstellar medium could have accumulated significant exogenous material on its surface, such as volatile ices and organics. And those materials would then be further processed by the continuous cosmic ray exposure over billions of years. Confirmed OH emission beyond 2.5 astronomical units, which is very rare, mind you, is strong evidence that long-term implantation of ices and organics in the outermost layers of 3I Atlas took place during its long journey through the interstellar medium. The structure of 3I Atlas would be a rocky metal, thermally metamorphosed, high-strength body covered by a porous regolith. That's just like a dusty material on the outside. Somewhat analogous to an asteroid. It would have a strong and metal-rich interior. 3I Atlas has many of the characteristics of trans-Newtonian objects, TNOs, and has a special affinity with Cr carbonaceous chondrites, a rare type of asteroid richly abundant in nickel and organics. Indeed, early observations of 3I Atlas revealed that it had anomalous volatile ratios, CO2 to H2O, of about 8, which is a 4.5 sigma deviation above values typical for solar system comets, and a CO to H2O ratio of about 1.65. In carbonaceous chondrites, these Cr carbonaceous chondrites, iron nickel metal, or FeNi metal, is rapidly corroded by liquid water, producing clusters of magnetite, Fe3O4. The corrosion of metal can drive Fischer-Tropsch reactions, which would explain the high abundance of CO and CO2, and that is a pathway for the production of complex organic molecular building blocks of life as we know it, such as amino acids, nucleobases, sugars, and more. These reactive metals are also able to produce complex organics in very short timescales due to their catalytic properties. 3I Atlas experienced a rapid increase in brightness, about 2 in apparent magnitude, starting at 2.53 astronomical units. That was about September 5th, September 7th, a distance from the sun consistent with the onset of water ice sublimation, suggesting that 3I Atlas contained abundant volatile ices and entered into a new sublimation regime due to solar heating. Because of its relatively fast 16-hour rotation, how the brightness increase was sustained and not an outburst, it's possible that this resulted from widespread global cryovolcanism across the entire ice-rich surface of 3I Atlas, and not just from localized regions like is typical with comets. Imaging after perihelion has showed intense activity with multiple jets extending at least 50,000 kilometers from the nucleus, as well as a typical anti-sunward tail and a rare sunward facing jet/tail. Wavy filamentary structure has been observed in these structures, like the jets, and that's a hint as to the plasma nature of 3I Atlas. Activity on 3I Atlas is now dying down as it has begun dimming in brightness, and its anti-sunward tail is getting shorter and fainter, though its sunward facing jet tail appears to be growing even larger and brighter. The closest approach of 3I Atlas to Earth is around December 19th, and Earth will orbit through the perihelion region of 3I Atlas March to April of 2026. So a lot of really interesting updates and developments as it relates to 3I Atlas as a result of us now having a better understanding of the type of organics that can be found on an asteroid thanks to the Osiris-REx mission for asteroid Bennu. And that data just came out in the past couple days. And then also all these observations that we've gathered of 3I Atlas across time, combined with the other observations that we've made of D-type asteroids, TNOs, CR carbonaceous chondrite, asteroid fragments, all that is painting a picture now which is fairly coherent and not in the realm of complete fantasy. So that is the update for you on 3I Atlas. I'll keep you up to date with any new developments that come in, but this story is getting very dynamic as it relates to the angle for Interstellar Object being some sort of seed of perhaps life from a completely different star system. So yeah, very exciting developments. I expect there to be some new updates in the days and weeks ahead. So if you like the video, smash that like button. Again, I've been your host, Stefan Burns. We cover what's happening here on Earth energetically. So we look at earthquake activity, volcanoes, we look at geomagnetic storms and severe weather events. Right now, actually, as I'm filming this, we just had a burst of geomagnetic activity, a G3- storm. So maybe you felt that. We look at solar activity, space weather, planetary resonances, cosmic and interstellar forces, and comets, and more. So I bring all that together, present videos almost daily. If you like the sound of that, then please subscribe. Thank you so much. Wishing each and every single one of you well. Please take care of yourselves. I'll see you all in the next video.